Here is an example of how we use nodal analysis to solve a circuit such as this. Remember that nodal analysis method is specifically useful for something with current sources like the circuit you see before you. Here we have a 10 amp source, a 5 amp source, and we have 3 resistors. And so let's follow these steps that we need to follow to solve this circuit. What we're trying to find is the unknown voltages at the nodes and the unknown currents in the branches. These unknown currents are labeled I1, I2, and I3. Notice that we're using lowercase i's to indicate the currents in the branches. We typically use capital I's to indicate the current sources. Some books do this the other way around, but as long as you keep it straight, that's fine. Remember, here are the steps. Step 1. Find a reference node with a known voltage. Step 2. Assign voltages to other nodes. Step 3. Assign currents to each branch. Step 4. Apply Kirchhoff's current law to each node. Step 5. Define current using Ohm's law. Step 6. Substitute the current definitions into the node current equations. And Step 7. Set up a linear set of equations and solve for the unknown voltages. So here we go. Step 1. Find a reference node with a known voltage. Here we have a node down here at the bottom. We'll go ahead and connect that to ground and call that 0 volts. This will be our reference node. Step 2. Assign voltages to other nodes. There are 2 other nodes we've already labeled V1 and V2. Step 3. Assign currents to each branch. Notice there are 3 branches, so we assign 3 currents. It's always a good idea to try to guess what the direction each of the currents will be. Notice we have a strong current source pushing current in this direction to this node right here. We have another current source driving current in this direction. It's reasonable to expect that current will flow in this direction to this branch and in this direction to that branch. Now assume we were wrong in our guess. Let's say that this current was actually flowing in the opposite direction. Well, what you'll find is if you do everything correctly, you'll get a negative value for this current, which then indicates that the arrow is drawn in the opposite direction. That means the negative value with an arrow drawn in the opposite direction still gives you the correct answer. In the end, what you can do is change the negative value to a positive value and switch the direction of the arrow. The next step is step 4. Apply Kirchhoff's current law to each node. We have 2 nodes, which means we're going to add up all the currents entering the node and set it equal to all the currents leaving the node. This node right here, V1, we see that there's a 10 amp source entering the node, a 5 amp source leaving the node. Also, I1 is leaving and I2 is leaving. That means for the first equation, this is step 4. I like to label my steps. Step 4, 10 amps entering the node equals 5 amps leaving plus I1 leaving plus I2 leaving. So this is our first equation using Kirchhoff's current law. The second equation we get by looking at node V2, right here. 5 amps is entering the node, I2 is entering the node, and I3 is leaving the node. That means 5 amps plus I2 must equal I3. Next step, step 5, define current using Ohm's law. We're going to find an expression for each of the currents in terms of the voltage difference across each of the branches and the resistance in each branch. So let's label this step 5. I1 can be defined as the voltage drop from V1 to 0. That would be V1 minus 0 divided by the resistance on that branch, which would be 6 ohms. Here I2 can be defined as the voltage drop here, which is V1 minus V2 divided by the resistance of that branch, which is 4 ohms. I3 can be defined as the voltage drop here, which is V2 minus 0 divided by 2 ohms, which is the resistance of that branch.